Welcome to the Blood Transfusion Center. Today we're going to determine the blood type of synthetic blood samples using antisera to the A, B, and Rh antigens. So here is our blood. We have we have blood from 4 different patients. And here's the serum. So all of these contain antibodies. So anti-A serum means it's going to contain anti-A antibodies. So if you added this to like type A blood, it would clump with the A antigen. If you added A to type B blood, it would not clump because type B blood does not have the A antigen. The B one is yellow, so type B antibodies in there. And then this is the Rh, or sometimes referred to as D antigen. So this has the Rh antigens. This is a little spot plate where you can mix like the blood and the anti-A antibody together. And then here would be the blood with the anti-B antibody and the blood with the anti-Rh antibody. Notice that we have different colored mixing sticks, like these little toothpicks. So once we add the serum, we're going to stir it to make sure they mix. This is what it looks like, the clumping that I was talking about earlier. So remember that red blood cells have antigens on them, like type A blood this would be the A antigen. Or if instead we're saying like we're looking at positive blood, then this would be the Rh antigen. If it was A positive blood, it would have the A and the Rh antigens on it. And whenever they come in contact with their antibodies, they agglutinate, which means the antibodies attach to the cells and basically cause a big pileup. This is how our body marks things to be destroyed by our immune system, because like a big clump of cells like this is easy for a macrophage to come and find and destroy. And this is what it looks like in real blood. So this over here would be no clumping. This over here would be clumping. So thinking about all of that, I want you to kind of design a procedure. Like how could you use these materials to determine the blood type of our 4 patients? Hopefully you came up with something like this. We are going to place 3 drops of blood in each well of the blood typing slide. Then add 1 drop of antiserum to each well according to the label. We want to be able to know what our results mean. Use a mixing stick to combine the blood and the antiserum, again using the right color. And then finally we're going to wait at least 30 seconds and then observe what happens. So we're going to look and see if it clumped or it didn't. So here's sample 1 before so that you can compare. So none of this is clumped because nothing's been added to it. And here's sample 1 after. So right away, I noticed that we see clumps with the anti-A antibody. If the blood clumped with the anti-A antibodies, A antigens must be present. So I know that this could be type A blood or it could be type AB. We need to look at the next sample to see. Type B blood, or the type B antibody, does not have any clumps. So B antigens are not present. So just from these 2 results right here, I know that this has to be type A blood. And then finally, when we look at the Rh, there's no clumps again. If it didn't clump, that means no Rh antigens are present. That means it must be negative blood. So this is A negative blood. Here's sample 2 before, and here's our results. And this would be no clumping. This one, I tried to like spill it so you could see there is clumping here. It clumped with the anti-B antibody and no clumping with the anti-Rh antibody. Go ahead and analyze those results. Here's sample 3 before and sample 3 after. This is clumping. I know it looks kind of weird, but count that as clumping. No clumping, and over here, no clumping. Analyze those results. Don't be alarmed if you get the same blood type as one that we've already done, because my blood was going bad, so it didn't clump always when it was supposed to. Sorry. And here is sample 4 before and after. So no clumping, and even though that looks different, that does count as clumping. Analyze those results. And now we have some conclusion questions. Use the results from the serum test to determine the blood type of each sample. So this time we were just adding the anti-A antibodies and the anti-B antibodies. We don't have the Rh serum here, so we don't know if this blood is positive or negative. But hopefully you got these results. If you add anti-A and it clumps, A must be present. If you add the anti-B antibody and it clumps, B must be present, so it must be type AB blood. And then down here, the opposite, if it doesn't clump, there's no A antigens. If it doesn't clump, there's no B antigens. This would be type O blood. If you performed an antibody serum test on A positive blood, which antibodies would you expect it to agglutinate with? Tom and Jane participate in a Red Cross blood drive. Both are first-time donors. As part of the screening process, their blood is typed. Tom is A positive, Jane is AB positive. What ABO antibody is found in Tom's blood? What ABO antigens are found in Jane's blood? Someone who is Rh positive can receive Rh negative blood. However, someone who is Rh negative can't receive Rh positive blood. Let's think about that for a second. Remember, when we donate blood, we're only donating the red blood cell, not the plasma. So we're not donating any of our antibodies, just the antigens on our red blood cells. So someone who is Rh negative does not have the Rh antigen, so they would have the anti-Rh antibody. So if we took a red blood cell with the Rh antigen and tried to add it to them, it would clump with their antibodies. So that's no good. What would happen if a woman had Rh negative blood and she was pregnant with a fetus with Rh positive blood? The first pregnancy would be fine because the mom would not have any anti-Rh antibodies unless she has encountered Rh positive blood before. So with ABO antibodies, the anti-A antibody and the anti-B antibody, we start making those a little bit after we're born, and they're always in our blood. Most antibodies are not like that. Most antibodies we only make in response to like a antigen or an invader coming into our body. So we don't make anti-Rh antibodies until we encounter that Rh positive blood. Unfortunately, when the mom is giving birth, the blood is going to probably mix. Like when the placenta detaches, some of the baby's red blood cells are going to get into her body, and that will cause her to start making anti-Rh antibodies. That's not good. Nowadays, we can treat this with something called RhoGAM. It's a serum that contains anti-Rh antibodies. It clumps with the Rh factor, so it does it instead of the mom's immune response. So RhoGAM is going to clump all of the baby's antigens, and then the mom stays fine. And honestly, the mom's body doesn't even know that she encountered it. This is the same science behind giving a vaccine. We're giving someone the antibodies instead of our immune system having to make it on our own. If the mom has not been treated, so she does start making those anti-Rh antibodies, and she becomes pregnant again with an Rh positive baby, this is not good. Her antibodies will cross the placenta and destroy the baby's red blood cells. So, fatal condition if not prevented. And here is a diagram of that, because I know this can be confusing. So an Rh negative person does not have antibodies. If she has not encountered Rh positive blood, she does not have antibodies. And then here's our little Rh positive baby. Everything is going fine. Then when the baby delivers, the blood mixes and she starts making the anti-Rh antibodies. Those little green Pac-Man represent the anti-Rh antibodies. And then the next time she's pregnant with an Rh positive baby, her antibodies are going to destroy the cells. This would result in death, or if the baby's born, a disease. Fortunately, this could be prevented with RhoGAM. If we insert RhoGAM right here, we prevent the blood from mixing and we prevent mom from making these anti-Rh antibodies. Thank you.